Hello, and welcome to this demonstration of the Waterworld Ecosystem Service Assessment Tool. Today, I'll be showing you how to use this system at the free Scientist user interface. We're going to run a baseline, and we're going to do scenarios of climate change and land use change. I'm signed in as a scientist, and in order to get started, we're going to focus on the area that we want to simulate. So for today, I'm going to Colombia. So I type in Colombia in the box here, click go, and you'll now see that we will focus on the area in Colombia. Now there's two resolutions that we can run Waterworld in. We can run 1 kilometer resolutions at these large blue tiles, or we can run the system for 1 hectare resolution on these small purple tiles. These are roughly 1 degree by 1 degree, which is roughly 100 by 100 kilometers, and the blue tiles are 10 degree tiles, which is roughly 1,000 by 1,000 kilometers. Now the system will always run the tile that is highlighted. So in this case, if I select 1 kilometer up here as the resolution, it will run this large blue tile. If I select 1 hectare, it will run for this small tile here. So I'm going to leave this to 1 kilometer, and I'm going to click step 1, define area. Oh, I should first give this a name. Always need to give a runner name, and as you see, the system will tell you if you forget a step. So I can now define my area, and what we can see now in the top here is that our run has changed from the default Africa run to Colombia. So whenever you are not sure where you are, have a look at the breadcrumb trail here. This will also tell you what alternative you're in. So currently we're setting up a baseline, but if you've done a policy exercise, then the name of that will appear here as well. You can also see what system you are in. So we're currently running Waterworld version 2. Sometimes this doesn't update, in which case you just hit refresh. And this is always good to click just to make sure what run you're in. So we've set up our run, and we are now ready to move on to the next step, which is prepare data. So on the left here, we have the following steps. So we now click on step 2, and this will open up a new window. And we have some options here, although these are all locked. That means they are restricted for the user type that we're in, which is scientist. But these options become available, as you can see here, different user level types that are licensed. But all we need to do here is to copy over data to our workspace. So click on that, and what the system will do now is it will copy over the files from the Simterra database into your own workspace. This will take maximum a few minutes. If you hover your mouse over these little green blocks, you can see what the system is doing. Get a message now that our data is now copied over to the workspace, and we can have a look by clicking on the plus minus next to show workspace data, and this will show you all the data sets that are necessary to run Waterworld. And as is mentioned here, the data sets that can be visualized and downloaded from this list depend upon our licenses with data providers. So some of these layers here, or data, you're able to view and download, but most of them are restricted. However, you can have a look at the statistics of the maps. So just going to scroll through look for a map, for instance, total annual precipitation. If I click on the show map stats here and I hover my mouse over results, then you will see some of the statistics. So the total annual precipitation for this 10-degree tile has a mean of 2,500 millimeters a year. So now that this data is set up, we can close the window and we can move on to step 3 on the left here, which is to start the simulation. If I click that, all I have to do here is click Start, and this will set the simulation running. And this will take about 10 to 15 minutes to run, and the system will tell you what it's doing. And also, as it says here, you can just close this, or you can close down the computer. Once the simulation is set to run, it will run on our servers. When you next log in, the run will have finished, and you can have a look at the results. Okay, so the simulation has now finished, and we can close the simulation box, and we can now have a look at some of the results. So we're going to skip step 4, because that is the scenario exercises. We're going to go straight to step 5 and look at the map results. So this is going to open up a new window, and here are key results. Under all maps, on the super user level, you will be able to see all the other outputs produced by Waterworld as well. Using the scientist interface as we do today, we can only have access to these key output maps. So one of the key output maps obviously is the rainfall, which is modified for topography. Let's have a look at that map first. So viewing the maps is as simple as clicking on these icons here, the green icons. That allows us to have a look at the map. These values are pixel-based values, but we can also aggregate these over other maps. So if I click on View By, the system will pull up a range of maps that I can use to aggregate my values over. So in this case, for instance, I can look at my precipitation by major subbasin. And here you go. You can see we have very high precipitation on the coast here, much lower on the coast. Other options we have with the map viewer is we can change the image. So we can change the color scale, we can set the minimum and maximum values, so we can cap the values. You can download these maps in a range of formats. Citations are given below here. And we can also view these maps in Google Earth or in Google Maps. If I click on the Google Maps icon, the map will now be draped over Google Maps. There we go. And we can toggle switches on and off. We can set the opacity, and if I move the map and place the crosshair over these values, it's really high. And I click query, I get the value at that point. So we have 10,741 millimeters a year of precipitation. If I click on inputs, I can then query all the inputs, the map at this point. This is a function that is very useful, not for this particular map, but for the water balance map. You'll be able to see the components that make up the map at this point. So if I close this, let's have a look at some of the other maps. So we have main output map, obviously, since this is the water or hydrological model, we can look at the water balance. So let's have a look at the baseline water balance. And not surprisingly, because we had really high rainfall in this area, our water balance is really high there as well. Some of the other maps I can show is we have erosion maps as well, and we also have a water quality map, or the mean annual human footprint of water quality. That is the percentage of water that may be polluted. And this obviously ranges between 0 and 100 because it's a percentage, and it gives you the areas where there is likely contaminated water. If you want to know more about how this is calculated, then have a look at the documentation on the left here on the main page. Right. And finally, we can have a look at the runoff map. And this is one of those maps where it is very useful to set your minimum or maximum. Let's see what that does. And this allows you to filter out the lower values and focus on the main rivers, as you can see. And this is runoff values filtered for the high values, so you only see the main river pattern here. Right. I'm going to close that now, and we can now, once we've run a baseline, we can now do a scenario analysis. So to do that, I can go to policy exercises, which is step 4. I click on there, and there's a number of options here. And as it says here, click the interface tool you would like to use. Tools available depend on your license access level. Because we are using the scientist level today, we can only run climate change or land use cover change scenarios. So let's have a look at the climate change scenarios. There's a couple of options here as well. We can run the GCMs. We have downscaled IPCC GCMs in there, or you can set up your own simple scenarios. Click here, and that means that you can just change the temperature seasonally and change the precipitation as a percentage of the current precipitation. And there's a couple of other options here that are only available for different user levels. So let's use one of the built-in GCMs. So I'm just going to call this change, and then we need to make a selection. We have the fourth assessment report GCM there. We have IPCC for 4 scenarios, emission scenarios, different downscalers. And now click here, you can see you can run scenarios for individual models, or you can run for the mean of all models, or the mean of all models minus 1 standard deviation, or +1 standard deviation. So now I'm just going to select one model, and then in this case there's only one time period, which is the 2050s. If I now click submit, then the system will start setting up this scenario. And again, you can see what it's doing by moving the mouse over here. And this will take another few minutes before the scenario is built. Okay, so the scenario is now built, and once that's done, we get a few options. We can have a look at the baseline and the scenario and look at the differences, or we can run it straight away. But let's have a look at the differences first. So do a comparison. This is good practice to always have a look at the scenario you built and see whether it makes sense. So it's now building comparison between baseline maps and scenario maps for those that have changed. In this case, temperature and precipitation. You can now see at the top as well that we have the run Columbia with the scenario of AR4 A2A 2050s. So the comparison is now built, so we can now have a look at the change in data for this scenario. So as you see, we have temperature and precipitation changes. So let's have a look at what it looks like. So this is monthly, so we can look at, for instance, how does the total precipitation for January change. And so on the left here we see what the baseline precipitation is for January, and on the right we see the scenario precipitation. And just by looking at statistics, we can see that the precipitation increases for the tile as a whole. If I hover my mouse over these values, I get the exact values. So from a mean of 91, we go to a mean of 93. And obviously there will be spatial differences as well. You can have a better look at these maps by clicking on the display to your browser. That will open up the viewer as we have seen before. Underneath it, you also get the distribution of values, histograms, and so you will get these maps for all the maps that have changed for this scenario. So it's always a good idea to have a look at the scenario you've built, particularly when they are more complex scenarios, before you set to run going. So I can now close this, have a look, and we can now set this scenario to run. Click on this. As you can see, you don't have to click start. In this case, it will set the run going straight away. So this will take, again, about 10-15 minutes for the system to run through. Okay, so we've now finished the run for the scenario of climate change. So I can now close this and we can have a look at the results. So again, I click on step 5, results. And what we now see is we see the same output maps, but we have a different icon next to them. So now we can look at the change from the baseline. So if I look at the main map, the water balance map, and I click on compare to baseline, I will now prepare a difference map. So as you see here, this is the difference between the scenario and baseline. So we see a increase of water balance in many areas, but we can also see some pixels along here and here that show a decrease. We can also still have a look at the baseline on the left here and the scenario output on the right. So overall, the mean in the baseline was 2065 for the tile as a whole, and for the scenario we have 2068. So we have a slight increase in water balance overall. And then all the way at the bottom here, there is a percentage change map as well. So I have to click on the plus minus to see that map, and we can see that there's this little area here where we have a decrease in water balance, but overall the rest shows an increase. And obviously you can still click on the green icons, and that will give you all the same options that you saw when we did the baseline. So for instance, you could set this to all positive numbers by changing min and maximum. And so you can then see that most of the region shows an increase in water balance. And obviously you can do the reverse to look at the negative numbers as well. And again, you can do the view by, or we can overlay this onto Google Maps. All the options that we had before, such as query and shows inputs. Now you can see, because this time that shows the water balance map and not the rainfall map, you can see that there are a number of variables that contribute to this map. Click on them all individually, and you can download these values in Excel as well. I'm going to close that now. So that's our change. Water balance. Similarly, obviously, we can look at changing runoff. Changes in runoff. Cubic meters total. So we expect an increase here as well, of course, because we have an increase in water balance. We can also set this to positive. That shows us the areas where we see an increase in runoff. So that's running a scenario. Close the output list. There's two more steps that I haven't explained before. So we have step 6, which is the results, but then stats. That should give you time series. And then we have a narrative, which tells you what happened in the run. So for the alternative run, water balance was an average. And you can click on show and it tells you the values. And in this case, because we're already in the scenario run, we have baseline and alternative. So that's quickly how to do a baseline and climate change scenario. Let's have a look at some of the other policy exercises for land use change. Now, in order to, I need to refresh this to see that we are in the scenario run. In order to do another scenario, we need to return to the baseline first. So I'm going to click on Manage Simulations on the left here, and that opens up a page where I can choose the resolution. Obviously, we've done a 1 kilometer run, so I'm going to leave that to the default 10-degree tile. And if I then click on Show Me, it shows me all the runs that I've done. So I have a total of 3 runs out of a maximum of 7 in this case. And it tells me when I set up the run and whether it's completed or not. And underneath it, I get the alternatives. And so once you are done with a run, you will have to delete the runs off the system because they take up considerable amount of space on the servers, and that's why you're only allowed to store a number of runs, 3 runs for the scientist user level. And so you won't be able to do any other runs until you've deleted all ones. In this case, we're still good for space, but I do need to return to the baseline because we can only run scenarios based on the baseline. So I'm going to choose the baseline, close the window, and refresh this, and that will bring me back to the baseline. I can now go back to step 4 policy exercises, and we can have a look at some of the other interventions that we can do. So let's have a look at the land use and land cover change to assess the impact of land use change. There's a number of options here. We can look at changing the forest cover, so forest to herbaceous cover or herbaceous cover to forest, basically deforestation and afforestation, or we can create our own land cover type. There is 3 functional types of land cover in the system: tree, herb, and bare soil functional types, and we can change those values on a pixel basis. For now, I'm going to stick with doing a deforestation scenario. So we have 2 options. We have the predefined rules, or we have define your own rule. And in the predefined rule, we can deforest by putting a minus, or we can deforest by putting a plus each pixel by a given percentage. So for instance, I could do a deforest scenario where I say, let's deforest everywhere outside protected areas, so minus 100. And obviously I can choose any of these to set up my scenarios. So I could also deforest near roads and rivers or inside protected areas, or I could reforest inside protected areas by typing plus 50%, for instance. So that's using the predefined rule. And then I can also say, what do I want to happen with these areas that are deforested? So I can define them as unchanged, or I can set them to grazing, cropping, natural protected, and I can also give them an intensity of use. The other option is to define your own rule, and this means that you can target where you want your deforestation or reforestation to take place more specifically than in these scenarios. So if I say defor each pixel, so let's do minus 50 for 100% of land, and then I have the option to pick a map. So let's have a look at, for instance, the local administrative boundaries. That was not a very good choice. Let's look at protected areas. So this will bring up a map of protected areas. Based on the WDPA database. And I can now target specific ones that I want to target for deforestation or reforestation. So I can select an individual one. To do that, I need to look at the actual values. To do that, I need to click on Google Maps. That will overlay this map onto Google Maps. And I can now, for instance, this one here, get the specific value. So if I click on Query, I get the value of 131. I can then copy that into this box and say deforest minus 50% of all the land where this protected area map equals 131. So now the deforestation will only take place in protected area 131, which is this one. And I can add numbers to that. So I would also like to deforest this one by 50%. I get 138, which I can just copy paste and place underneath it. Yeah, 131 and 138. And you can add as many as you like. And obviously you can choose any of the other maps in here as well to target your deforestation scenario. I can also, by clicking on other rules, add some rules. So I can ignore or I can add other areas. So if I'm not only interested in protected areas but also in key biodiversity areas or something like that, then I can add values for that as well. And finally, I can set my converted areas and change them to another land use type. So once you've set up that scenario, let's deforest all of it, I can check and submit, and that will set up my scenario. And again, that will take a few minutes to set up. So the scenario is now built, and again we can click on Show Baseline and Scenario, and that will bring up this map, and that shows you the changes in the map that are involved in setting up this scenario. So we have croplands, pastures, herb covered ground, tree covered ground, protected areas, and wetlands. These are all the input data sets that are involved in setting up this scenario. So we can have a look and look at some of the changes. And at first glance, we can see that there is not much change. And that's because we targeted the deforestation only in a couple of small areas along the coast here, where we obviously didn't have much tree cover to disappear. And so the changes under this particular scenario are minimal. But let's see what happens if we run the scenario. So I'm just going to click on Run Scenario, and again that will set the system running straight away and run through this scenario. Okay, so we have now finished running the scenario. So similar to the climate change scenario, you can now have a look at some of the changes. Again, make sure we're in the correct run, click on Refresh, see some scenario that we set up. And so by clicking on Step 5, Results Maps, we can then have a look at the changes in key outputs, which is the change in water balance. Now, unfortunately, I think because of the scenario we have developed, there is no change. There is no change in the water balance. So this is the result of the scenario that we chose, that we actually don't see any change in the maps. However, I guess you get the idea of how to set up a scenario of land use change and how to run it through. So I'm going to close this now, and I think that concludes what I want to share with you today. I hope this has been useful. and I hope that you will now start using the system, or if you already use the system, you can sign up to one of our trainings if you want to know more, or have a look at some of the other trainings that we have posted online that you can work through in your own time. Thank you very much for joining today, and we'll hope you start using the system. Please have a look at the website policysport.org, and there's contact details here as well. And there is also a list of our web-based or our physical trainings in London that you can attend free as well. Thank you very much.